What's up guys, I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. So in this video we will be looking at part 3 of our MatPlotLib tutorial series. So just before we actually begin, I'd like to just reveal to you, or show you rather, the contents of these two files that I have here. So what I'd like you guys to do is pause the video, at these 2 points in time and create your own files. You can, replicate the exact same content I have here. Essentially, it's sample data1.txt, so they are both text files, and I have sample data2.txt, and it is the same, but it's just another column of data that has been added here. We have a third column where we have 6, 5, 4, 3, 2, and 1. So you guys create these files on your local machine in the folder or directory you are working with, and we will utilize this in this specific video because essentially, you guys know, we worked with in the previous video plotting multiple curves on a single set of axes. Now what we are doing in this video here is we are going to be plotting curves again, but this time we are going to plot these curves, our gradients, from file data. Okay, so data that's stored in our files, we can actually read the data in and then plot a visualization. So that's what we will be doing now. So let's actually proceed to do it. So the first and foremost, one of the most minimalistic approaches, a pure Python approach to actually get this done, you guys know, it will be to use the file handling approach. So built-in Python file handling methods and techniques will utilize that. So what we can do is import matplotlib.pyplot as plt. For this example, we are going to utilize sample data1.txt. So let's go ahead and see to it that we get it done. So first things first, what I would like to do is I will initialize an x and a y array. So what I can do is, this is probably something some of you may come across for the first time. It is very handy to use in your journey with Python. Essentially, Python supports multiple assignments on a single line. Okay, so that's something we can do. So I have x and y, and I set them equal to be an empty list. So that's fine. Now, what I'd like to do is I will say for line in open. Open is a built-in Python keyword. So within this, we shall pass sample data1.txt. Let's open this in read mode. And within this for loop, I can say values is equals to, I can have a list comprehension here. We can float s for s in line dot split. So essentially we will split the lines, and that will give us, since we have these pairs or coordinates, we will float them because of the fact that they are numbers. We want to retain their numerical data type. So that is fine. Now what I can do is, since we know for a fact, I just explained to you guys that we are reading this as a list. So essentially one element contains two values. So what we can do is we can, within this for loop, assign the values to the x or the y list, right, appropriately. So the first value out of this data point or this pair, it will obviously be the x value. So what we can do is we can say x dot append, and within the append we'll say values of 0. You guys know Python is a 0 indexed programming language, so values and 1, that will be the y value. So essentially after this for loop runs, we'll have two lists, x and y, containing numbers itself. So what we can do is I will run this. So let me actually run the entire script, and so I am brought to my directory in which I'm working with. So I ran the entire script. This is just the graphs we worked with earlier. It's all this code here. So that's there. Anyway, let's now actually, so I am in the folder and now I can do Control Enter. Let me provide you guys with a small insight as to what X and Y looks like. So it's nothing difficult, guys. It's just these numbers here that have been read in and kind of processed. So now we are ready to plot. Let's do plt.plot. Again, we are plotting a line graph. So x comma y, plt.show. Control enter, and here we have our graph. That's the graph, guys. So that is what we just did, is we plotted, or we drew a curve using file data. Okay, so I will add that as a comment. Plotting curves using file data. So that's what we just did. Now there are several other ways or techniques we can actually do what we just did. So essentially what I mean is there's more than one way to plot a curve using file data. So let's play around with this. I can show you guys more examples. So I will create a new cell, import matplotlib.pyplot as plt, and now what we are doing, this approach, it is again using inbuilt Python syntax. But if you are familiar with list comprehensions and the zip functions and so on, this is another equivalent way to do what we just did, but it's just that we are doing this in one line. Okay, it's a one-liner. So let's do with open, and what we can pass here is the name of the file. So string sample data1.txt. You guys know we want this in read mode, and we'll add an alias for this file object, call it f. You guys can call it anything you like. So xy is equals to zip. Within this we can say asterisk. Let's do list comprehension here. So float s for s in line dot split. So essentially it's the exact similar syntax to what we had before, but you guys know Python is object oriented, so you can take a method and slap it at the end of an existing method or function or so on. So that's what you can do. So everything here is condensed into one line. So that's what we have, a zip function that is going to create for us the data points. So plt.plot x comma y, plt.show, and here we have this. So I will take out or remove that visualization. I will press Control Enter, and it is the same, guys. We can view x, we can view y, it is the same. It's just that now or previously in this here example, the first one we did, we had lists, and in the second one, using the condensed version as a result of the zip function, we have tuples of elements. So not a major change. So let's go forward. So one more thing that I'd like to demonstrate to you. So what you will realize, right, is that during the data loading, so this is the data loading portions, opening the file and so on. During that portion, essentially what you'll notice is that we have not used, error handling or any form of checking or so on, integrated into our code. So this is why now you're probably asking the question that when I demonstrated earlier in the NumPy tutorial, if I'm not mistaken, when I showed you guys a simple example of file handling, I mentioned that it is very good practice to always use file handling, or rather always use error handling techniques when you are performing file handling. So we did not do that here, but now that is not a major kind of train smash, because of the fact that the width function or built-in keyword, it's actually what it does is it automatically closes the file for us. And now also I should reinforce that you guys know, right? It is often said that a good programmer is a lazy programmer. Okay, so taking this into consideration and keeping that statement in mind, right? What we just did is we used built-in Python features and methods to actually perform our task. Now, you guys know, right? In the first example, we were working with lists, but we were working with a standard Python list slash array object. So you guys may say, since we use NumPy so often, why not integrate it into our example? You know, can we use NumPy to do the loading of data? And the answer is yes, you can. We can, guys. So that's what I will demonstrate for you now. So these are all different ways to perform the same task, and it is super interesting. So import numpy as np, import matplotlib dot pyplot as plt. Let's do data is equals to numpy dot load txt, and these are methods that we are familiar with. We covered it during the numpy tutorial. So sample data1.txt. So I will run this, I will call on data, and as you guys can see, it is super intuitive and it makes life very easy for us. Okay, so this is why oftentimes you may come across the saying, a good programmer is a lazy programmer. So NumPy really does everything for us automatically. All we need to do is plot this data. So plt.plot, within this the x values will be data, a simple slicing operation, all rows but column 0 being plotted against data, all rows but column 1. So plt.show, control enter, and the graph is the same. So super interesting stuff, if you will agree with me. Now what's even more interesting, right, is that using this concept, what we just did of plotting curves or curve, we plotted one curve, right? Now the thing is, you have the ability to plot multiple curves from file data. So let me actually demonstrate for you how that is done. So now we are plotting multiple curves, from file data. So this is what we can do. Essentially what we need to do is as follows. So let me create a new cell, and now I shall do, you guys know the regular importations, import numpy as np. We shall do import matplotlib dot pyplot as plt, and now we shall do data is equals to numpy dot load txt. Keep in mind, guys, here I would like to work with this is what we will utilize to plot those multiple curves. So let's go ahead and do that. So sample data2 dot txt. Now a simple for loop for column in data.t. The T is basically a transpose method. It makes the rows the columns and the columns the rows, and essentially it will allow us, using the for loop, to cycle through the columns. So what we can do is plt.plot data, all rows of column 0 being plotted against column. So now I can do plt.show. Now essentially what's happening is I will run the script first, and then I will allow you guys to see it. So let me remove that. As you guys can see, we have three curves, or we have three sort of functions that have been plotted. Okay, and all of those points actually came from this one here. Now what you will sort of notice is that essentially what's happened is that the x values is actually the 0, 1, 2, 4, 5, and 6. That's the x values. And essentially what we did is, for column in data.t, I'd like to just give you guys insight in case you are wondering. See, the important thing is that you understand the logic. Now, take a look at this. Right? Take a look at exactly what is being plotted. Keep in mind that the x values are standard. Okay, it's the 0, 1, 2, 4, 5, and 6. Now, keeping in mind the y values that are going to be plotted, these are the three curves we see on this distribution. So I do hope this gives you a bit more insight into what exactly has been plotted. During that iteration, all you guys need to really understand is the T, the transpose method, that NumPy supports. So that is that. Now, this is all that I wanted to do for this specific video. Essentially what we did is, as you guys know, we have plotted curves using file data, and it is super interesting. Okay, very very useful, very handy. Essentially, if you are working with files of data and you require some form of on the go visualizations, using just about 6 to 8 lines of code, you'll enable yourself to get a good visualization of that data as a result of the combination of NumPy and the MatPlotLib package in Python. So with that, we will end the video here. Thank you guys for watching. Thanks for staying till the end of the video. Good luck with your work, and I will see you in the next YouTube video.